Okay, so here we are, and we are answering which set of points, A, B, or C, is closest to the YZ plane. So remember, the YZ plane, let's draw a quick picture of what that looks like. Um, so this takes a little bit of imagination here, but here's our positive X, Y, and Z. So for the YZ plane, what that means is that X equals 0. So we're talking about this plane, kind of this vertical plane here, where all the values there, all the X values are 0, and Y and Z can be anything. So what we're looking at then, if we're trying to find out which is closest to the YZ plane, similar to the problem that we did before, all we're saying is, which value of X is closest to X equals 0. So we're just looking at the X values. We've got 2.5, 0.9, 1.3. So which is closest to the YZ plane? 0.9 is the smallest. So which is closest? B is closest. Which one lies in the XZ plane? Well, if it lies in the XZ plane, what must be true? What must be true is that Y equals 0. So looking at these points, which one has a Y value that's 0? Well, here are the Y values, and we all know what 0 is. So again, a B is our answer for this as well. So which one is in the XZ plane? B, because that's the one where Y equals 0. And lastly, which one is farthest from the XY plane? So in the XY plane, X and Y can be anything, and Z equals 0. So which one has the biggest Z value? Certainly not that one. 3.2. So our answer, again, is B. So B is closest to the YZ plane, lies in the XZ plane, and is farthest from the XY plane. B is our big winner. All right, so we have an observer that's going to be watching us. Don't be nervous, but we have an observer watching us, and here's our observer right here. They're at the point 2, negative 3, 3. So I went over 2 in the X, minus 3 in the Y, and then 3 up in the Z. And here I am. And the question says, you start at, so that's our observer. You start at the point 3, 1, 1. So where is that? Well, we go out in the X, 1, 2, 3. And then we're going to go positive 1 in the Y and positive 1 in the Z. Oops. So here we are at the point 3, 1, 1. And then it says you're facing the YZ plane. Well, the YZ plane is this plane right here that we drew before. So that's our YZ plane. And so we're sitting there, we're facing this plane. So just as an indicator of the direction that I'm looking, let me draw in this little arrow that's showing where I'm looking. So here I am at this point, and I'm looking in that direction. And then it says you walk 2 units forward. So if I walk 2 units forward, where I am, facing the ZY plane. Well, the Z is my vertical position, and the Y is my horizontal position. So if I'm walking and this will take a little bit of time for you to sort of really sort of capture. I'm facing the YZ plane. Z is sort of my up and down, and Y is my horizontal position. So if I am to walk 2 units forward, that means I'm walking towards the ZY plane. That means that my Z value, sorry, my Z value and my Y value won't change. Um, if I walk 2 units forward, what's going to change is my X value. So let's use this to talk about my new walking. So I'm going to walk, I was at the point 3, 1, 1. I'm going to walk 2 units forward. And that brings me to the point. So there, my X value is reduced by 2. So instead of being at 3, 1, 1, I'm now at 1, 1, 1. And then I'm going to turn left and walk another 2 units. So now I'm going to walk left and walk this way. So I'm going to walk 1, 2, reducing my Y value. So I was at the point 3, 1, 1. I moved 2 closer, 1, 1, 1, and then I moved to the left. And now I'm at the point 1, comma, -1, comma, 1. So that's my final position. From the point of view of the observer, looking at the coordinate system, so from the point of view of this observer here, are you in front of or behind the YZ plane? Well, the YZ plane is this vertical plane here. And the difference that we need to look at are my X values. So since we're just talking about since we're talking about being in front or behind the YZ plane, we're just talking about the X value. So looking at the observer, my observer had an X value of 2, and my final position had an X value of 1. So independent of my YZ values, those are just telling me where I would be sort of a projection onto the YZ plane. But as far as like the YZ plane is uh, behind me, and the observer is in front of me. So in other words, if we were at the YZ plane, I'm one positive away to the X, and the observer is 2 positive away to the X. So the observer is further away from me from the YZ plane. Get it? So they're 2 distance away from the YZ plane. I'm 1 distance away. So if they were to look back, if this observer were to look back at the YZ plane, I would be closer than it. I'm only 1 away from the YZ plane versus being 2. So I am in front of to my observer, I'm in front of the YZ plane. What about this question? To the left or to the right of the XZ plane? Well, the XZ plane is, it's kind of hard to see, but it's the XZ plane is when Y equals 0. So when we say left, what that's saying is my Y value is less than 0. And when we say to the right, kind of convention says Y is greater than 0, because in our XZ plane, Y is 0. So if we look at my Y value, my final position is -1. So that means that it's less than 0. So I am to the left of the XZ plane. And last question, am I above or below the XY plane? That's just talking about my Z value. Is Z greater than 0 would be above? Is Z less than 0 would be below? So my Z value is 1, which is greater than 0. Therefore, I am above the xy plane. So um, this is a tricky question at first as you start becoming familiar with 3D space and plotting 3D space in 2 dimensions. But just be patient with it. Watch it again if it's confusing. Watch it again and again if it still is confusing. And if you're still confused, we can do further examples with this. Okay. Geometry question. Find the equation of the sphere of radius 5 centered at the origin. So, I mean, you know what this looks like. The center of the sphere is at the origin. The definition of a sphere means that all points on the sphere are a distance, and this should start ringing bells, are a distance of 5 from the origin. So here's our sphere. And every point on that outer part of the sphere is a distance of 5. Oh, I shouldn't have used that color. Is a distance of 5 from the origin. So distance of 5, distance of 5, distance of 5. Well, we defined our distance equation earlier. We know that, just as a review, distance equals the square root of x minus x naught squared plus y minus y naught squared plus z minus z naught squared. But since we're talking about from the origin, x naught, y naught, and z naught are all 0. Our point that we're measuring from is the origin, 0, 0, 0. So what would be my equation? Well, my distance is going to be 5. I want every point to be 5 units away. That's the definition of a sphere. Equals x squared plus y squared plus z squared. And if we wanted to write this a little bit sharper, it's just x squared plus y squared plus z squared equals r squared, but in this case, 25. And here's an equation for a sphere. Very similar to a circle. A circle would just not have the z squared component. All right, last question that we're going to look at, and we'll end with an easy one. It says, describe the set of all points whose distance from the x-axis is 2. So, if we draw our coordinate planes, in this case, coordinate space, that's no longer a plane. So we want the set of points whose distance from the x-axis is 2. So if here's our x-axis, we want so let's see how well I can draw a plane here. Here's sorry, we're not drawing a plane. Let's think about what this looks like. The distance from the x-axis is 2. Well, what that's really drawing, let's imagine a circle around the x-axis. So let's say that goes around the x-axis, and the radius of that is 2. But it doesn't matter whether the circle is there or the circle is here with a radius of 2. What we're drawing is a open cylinder around the x-axis. So we're drawing a cylinder around the x-axis that has a radius of 2. And that way, every single point is going to be, whether we're, just in the just in the y, just in the z, at any point on the cylinder for any value of x, independent of x, uh, we're going to be 2 away from the x-axis. So what does that mean? What that means is that our equation will ignore x because x can be anything. Our equation is that y squared plus z squared must equal 4. We're developing a circle, and that develops a circle, but more than just a circle, a sphere around, sorry, a cylinder around the x-axis. So for any x can be anything, but what's critical is that the y plus z squared must equal 4. And if that's true, then the point will be 2 away from the x-axis. Okay, so that's it. What we did in this video is we looked at 3D space, graphing, we looked at distance formulas, we looked at proximity of points to an axis. Sorry, not to an axis, but to a plane. This is spelled wrong. What else did we look at? Well, that's pretty much the bulk of it. The biggest thing now is just really becoming comfortable and familiar with seeing 3 dimensions on a 2D graph and being able to plot points and see planes and understand what graphs of equations would look like.